Hey everybody, just everyone's having a great weekend. Let's go ahead and get started. We're going to talk this week though about Lewis structures, right? So what are Lewis structures? Well, they are, these things. So Lewis structures, as you can see, are actually just models of molecules. And we're going to be using Lewis dot symbols combined with bonds and put it all together, and we get pretty cool looking infrastructures. So let's get started. Drawing a Lewis structure is really just about putting together all of the chemistry that we've already learned. And so where we want to start this journey is to determine the total number of electrons that we have to work with, which is to say the total number of valence electrons. Using the periodic table, counting in a period from the left only in the S and P block, I can see that phosphorus has a total of 5 valence electrons. And of course, chlorine has 7 valence electrons, but there are 3 chlorines. So then if we add 5 plus 21, we get 26. So students, the first step, i.e. count your total number of valence electrons, this is absolutely the most important step in drawing a structure. Because basically we can't build a structure with less than what we have available or with more than what we have available. Matter can't be created and it can't be destroyed. So to conserve mass, we have to ensure that whatever that we come up with, it truly has a total of 26 valence electrons. The next thing that we're going to do is draw a skeletal structure. A skeletal structure is a structure in which we've made choices or we've placed atoms, arranging them in some type of a way. So we're not going to put any electrons. That means that we're not putting any unshared or shared electrons throughout the structure. Again, a skeletal structure is just where we've positioned atoms around. So to give you an idea of what that looks like for PCl3, looking at my structure, the first atom or atoms that are usually listed. Now, this is not always true by any means, but it's usually a big clue that the first atom we see is going to be our central atom. So I'm going to place my phosphorus right here. And then I have 3 chlorines, and so it would kind of make sense if I positioned my 3 chlorines around. So this is our skeletal structure. And so you can just imagine, right, a skeletal structure is where we are just kind of moving or positioning these atoms around, figuring out where or how we want to organize this structure. So the next step is we are now going to add single bonds between each of our atoms. So that's pretty simple. Let's go ahead and do that. The next step is we're going to start adding lone pairs until every atom has met the octet rule. Notice that this chlorine here has 1 shared pair of electrons. That counts for 2 electrons. So then I need an additional 6 electrons, which means 3 lone pairs or 3 unshared pairs. So that's 1, 2, 3, 4, 5, 6. On our step number 4, we go around every atom and we fill their octet rule. Again, we're shooting for 8 valence electrons. Notice that the phosphorus only has 3 shared pairs of electrons, which 6 in total. So then that phosphorus just needs 2. So now that we're done with that step, we move on to our next step, which is step 5. What we want to do now is count up all the total electrons in our structure and compare to step 1, which is the total number of valence electrons that we had available. So to make your life a little bit easier, one thing that you can do is count as 2, 4, 6, 8, and so forth until you've counted up all of the electrons that you have placed in your structure. Or, even better and much faster, is if you were to recognize that on each chlorine there are 8 electrons. And so I could say that is 8 right there. Right here we have, obviously, 16. And then, of course, right here we have, obviously, 24. And then the last one that we didn't talk about are those 2 right there. And so we have, in total, 8 16, 24, and then of course 26. So our structure has a total of 26 electrons. So the big question is this: how does this number compare to the total number of valence electrons we counted in step 1? Let's go find out. And you'll notice that the two right here, they equal, which means that our structure is good to move forward. Now that we are done with this, we can move on to our final steps. These final steps are technically optional. They may or may not be asked or requested on any particular problem. So to be clear, this is our official Lewis structure for phosphorus trichloride, but we could enhance it somewhat. So let's talk about formal charges. So a formal charge is the number of valence electrons minus the number of shared pairs minus the number of dots. Okay, so what formal charge represents is how we have distributed our electrons. So here we go. Notice that each chlorine is the same in terms of electrons and how they are assigned. Each has 3 lone pairs and 1 shared pair. So the formal charge for each of these chlorines will be the same. The number of valence electrons is 7. Then we're going to subtract the number of shared pairs, which is 1 shared pair. And then, of course, the number of dots, which is to say the total number of electrons in the lone pairs. So the total number of dots would be 2, 4, 6. And so that would be 6. So we say chlorine has a 0 formal charge, which means then that this chlorine, and this chlorine, they all have a 0 formal charge. The formal charge for our phosphorus would be 5 valence electrons. We're going to subtract the number of shared pairs. There are a total of 3, so that would be 3 minus the number of dots, which is the number, again, the total number of electrons in the lone pairs, which would be 2. And again, you'll see phosphorus is 0 here, just like the chlorines. Notice that we've written our formal charge of 0 just like a charge. Anything that has a charge of 0, we don't write any number or any symbol to indicate that. It is left blank, if you will. This has no resonance structures, and you'll notice that this is not an ion, so we do not need any square brackets. So therefore, students, this is our final answer. This is our structure for phosphorus trichloride.